Hi viewers, this is Sri Ramulu. So this topic is logic gates, circuit which are used to process digital signal are called logic gates. Okay, circuit which are used to process digital signals means 1 or 0 are called logic gates. Gate is a digital circuit with one or more inputs but only one output. Right? Gate is what? It is a digital circuit and it contains one or more inputs but only one output will be there. The numbers 0 and 1 represent the two possible states of logic gates. So 0 and 1 represent two possible states. So what are those are given here? The two states can also be referred as here 1 means on, 0 means off, 1 means high, 0 means low, or 1 means true, 0 means false. Okay, so like this. So depending upon the case, whether one is on or high or true, 0 is off or low or false, that is depending upon the case only. Next, truth table. All the possible inputs and outputs of logic gate circuit represented in table is called as truth table. Right? All possible inputs and outputs of logic gates circuit, all possible. So generally here how many digital signals or digital levels are there, states are there? Two only, one 0 and other one is 1 or 1 0. Okay, so these two numbers, these two logic numbers, how can we represent, how many possibilities can be created, or how many possibilities are there? So see, 0 0 one possibility, 0 1 another possibility, 1 0 is another possibility, 1 1 is another possibility. So how many possibilities for two numbers? 4 possibilities are there for two numbers. So that is simply 2 square, 4 possibility. OR gate. An OR gate is a logic gate that has two or more inputs but only one outputs. Okay, OR gate is a logic gate. What? It has two or more inputs but only one output. See here, OR gate. This is OR gate. See, three inputs are there, one output is given. Output is always denoted by Y. Inputs are denoted by capital ABC. The output Y of an OR gate is high if any or all the inputs are high. Okay, so when Y is high, when Y is high, when any input or all inputs are high, any one input or all inputs are high, then only output is high. See here, any one input, so here one input is there, high, here one input is there, high, here both inputs are high are there, so then output is high. Okay, if any one input high or both all inputs are high, then only output is high, otherwise 0. That is also given. However, the output Y of an OR is low when all inputs are low. So when all inputs are low, then output is also low. It is called OR gate. So that is we call OR gate. Truth table of OR gate is shown in figure. So it is a truth table of OR gate. Okay. And next, this OR gate also explained by the discrete component. It is a discrete component or discrete diagrams. With this diagram also we can explain OR gate. How? First one, when both A and B are connected to the ground, ground means not giving any input, that is ground. Okay, when both A and B are connected to the ground, both diodes, here how many diodes are there? Two diodes are there. First see the diagram clearly. See, it is a 5 volts battery, A input, B input. Here we have take it output at RL. So it is diode D1, diode D2. This side P terminal, N type. This side P type, it side N type. Okay. When both A and B are connected to the ground, both diodes are non-conducting. So when connected to the ground, then what happens? They do not. This cannot conduct, and it also cannot conduct. Okay. Hence, output voltage is ideally zero. Okay, that means low. So when these two are not connected to the battery, then what happens? No voltage drop across RL. So that is why it shows 0 only at RL. In terms of binary, when A is 0 and B is 0, then Y is also 0 as shown in truth table. Okay. When A is connected to the ground and B is connected to the positive terminal of the battery, it is when it is connected like this. A is not connected. Okay. The diode D2 forward bias. So this diode becomes forward bias, and D1 non-conducting. D1 do not conduct. Therefore D2 conducts, and output voltage is ideally 5 volts. So at here we get 5 volts. 5 volts means what? 5 volts indicates in binary 1 it is meaning. 0 volts indicate in binary 0 means. Okay, binary 0 means that is 0 volt, binary 1 means that is a 5 volts. So like this, a 5 volts will appear across output. When A is connected to the positive terminal of battery and B is connected to the ground, here now A is connected, B is not connected. Diode D1 is on and diode D2 is off. So it is off, it on. So that means this voltage flows in this direction and appear here as plus 5 volts. That means 1 only. Okay. In binary, okay, I didn't explain this point. When A is connected to the ground and B is connected to the positive terminal of the battery, it is explained. When A is connected to the positive terminal of the battery and B is connected to the ground, diode D1 is on, diode D2 is off. Okay. So D2 off, D1 is on. Then current flows in this direction. Then voltage drop across here. It shows output high. High means output 1. In terms of binary, again voltage across is 5 volt. Okay. In binary, in terms of binary, when A is equals to 1, B is equals to 0, then Y is equals to 1. Next, when both A and B are connected to the positive terminal of the battery, both the diodes are on. The voltage is 5 plus 5 volts appear here. Okay. So when these two are connected, then current flows through both, and here voltage drop will occur. Then we will get positive voltage as 5 here. It indicates in terms of binary as 1. In terms of binary terms, when A is equals to 1 and B is equals to 1, then Y is equals to 1. A is equals to 1, B is equals to 1, Y is equals to 1. Next, AND gate. The logic symbol of AND gate is shown in figure. It is AND gate. See here, inputs are, and this is output. The AND gate is a logic gate that has 2 or more inputs but only one output. Okay, so 2 or more inputs but it has only one output. The output Y of AND gate is high. Okay, output Y of AND gate is high when all inputs are high. When all inputs are high, output is high. And output Y of AND gate is low when any or all inputs are low. Any one or all inputs are low, then only output is low, otherwise it is high. So by using discrete component, first see the discrete component. Here diode D1, diode D2, and now it is in reverse bias. This side N type present, it is a P type. Okay, so if you connect like this, it becomes reverse bias and it becomes reverse bias. In reverse bias, diode do not conduct, and here voltage we are applying it across RL. and that appear here at this point, at this point only. Okay. When both A and B are connected to the ground, both diode D1 and D2 are forward biased and hence they do not conduct, and hence they conduct current. Okay, when these two are connected to ground, when these two are connected to ground, then what happens, this positive voltage can make it forward bias and this also make it forward bias. Then what happens, all the voltage travels in this direction, and here you cannot find any voltage. Thus the two diodes are grounded, output voltage is 0 in terms of binary. When A is equals to 0, B is equals to 0, Y is equals to 0. When A is connected to the ground and B is connected to the positive terminal. Okay, when A is connected to the ground, B is connected to the positive terminal. Okay, positive terminal of battery, diode D1 is forward biased. Okay, right, diode D1 is, why, because it is connected to this one. Diode D1 is connected to the ground, then this voltage flows in this direction. And diode D2 is, see here, diode D2 do not conduct. Why? Because it is in reverse bias. Why? Because see here, to this positive negative terminal, here positive battery will be connected, so that is why it is in reverse bias, it is forward bias. So this conducts, so then what happens, all the voltage come here, then you cannot find any voltage across output. Okay, again voltage will be 0 in binary terms. A is equals to 0, B is equals to 1, then Y is equals to 0. Okay, next third point, this is for this. When A is connected to the positive terminal of the battery and B is connected to the ground, B is connected to the ground and A is connected to the positive terminal. Now diode D2 will conduct while diode D1 doesn't conduct. D1 cannot conduct and D2 starts conducting. Okay, so then D2 conducts, so the voltage comes and current flows in this direction, and voltage cannot drop at output, so all the voltage comes this side only, so then output is also 0. As a result, diode D2 is grounded and again output voltage is 0 in binary. When A is equals to 1, B is equals to 0, then Y is equals to 0. Third point on. Next, fourth point. When both A and B are connected to positive terminal of the battery, both diodes do not conduct. Okay, when both are connected to the positive terminal, so these two becomes reverse biased. Reverse bias means they do not allow any current. When it cannot allow, whatever voltage present at output, this voltage, it appears here only, it cannot come. Why? It cannot reverse bias, these two become reverse biased. Then what happens, whatever voltage present, that appears here only, so that means high voltage. Now voltage, okay, now the voltage, output voltage is 5 because there is no current through the RL. In terms of binary, when A is equals to 1, B is equals to 1, then Y is also 1. Next, NOT gate. NOT gate also called as inverter. NOT gate has one input and one output. The output is always opposite to the input. Okay, it always opposite, means if input is 1, output is 0, input is 0, output is 1. The presence of small circle known as the bubble always denotes inversion in digital circuit. Here bubble in C in diagram, bubbles is there. This is the bubble. Okay, you can keep this bubble at front side or back side also, like this. Okay, anywhere if you connect the bulb, then it is a NOT gate diagram. Okay, when A is connected to the ground, the base transistor Q1 will become negative. Okay, when A is connected to the ground, then what happens, this base of the transistor Q1 is what, it will become negative. Okay, see the transistor, This is the transistor here, plus 5 volts. RK, it is a RB. Output is here. Output here means whatever voltage drop here, that appears here only. The negative potential causes transistor to cut off and a collector current is 0. Right? When negative voltage is applied, then what happens? This transistor works in cut-off region. Cut-off region means it cannot allow any current. Okay, so output voltage, or at output 5 voltage will appear. Whatever how much voltage you are applying, that appear here only at RL. In binary terms, when A is equals to 1, then Y is equals to 0. Next, when if sufficient large positive voltage at A, when sufficient large positive voltage is applied at A, the base of the transistor will become positive. Okay, causing the transistor to conduct heavily. Okay, when transistor conduct, whatever voltage the present here, that voltage flows and reaches to the ground. Therefore the output voltage becomes 0. Okay, then no voltage appears across output, so it means across RL. In binary terms, when A is equals to 0, then Y is equals to 1. Okay friends, these are the basic logic gate. Okay, thank you.